Hi everyone, welcome back to Lulumath. This video is on completing the square with integer values, and the background knowledge that you will need is you'll need to know how to factor perfect square trinomials. You can find that video on lulumath.com or at the Lulumath YouTube channel. Now we need to know how to factor perfect square trinomials because when we are completing the square, we are creating trinomials that are perfect squares, and we're completing whatever is missing to make those perfect square trinomials. This will serve to be a very useful tool when we start to solve quadratic equations, as well as when we're looking at quadratic relations and quadratic functions. So we're asked to factor the following expressions. And just a reminder that a squared plus 2ab plus b squared is a perfect square trinomial, and it factors to a plus b quantity squared. And if you need a refresher on why that is, make sure you check out that video. So our first expression that we want to factor is x squared plus 12x plus 36. And I'm going to set up my binomials, and I know that if I multiply this first term in this binomial by this first term here, I will get this x squared. So I know I can just use x times x. I also know that these last terms multiply together to give me 36. So I'm going to use 6 and 6 because I know that my outer will result in 6x, my inner will result in 6x, and 6x plus 6x gives us this 12x that we're looking for. So in short, this factored form is just x plus 6 quantity squared. Now, because my leading coefficient here is 1, it makes things a lot easier for me because I can just take this 36, take the square root of it, and the square root of 36 is plus or minus 6. Or I could take this 12 right here, divide that in half, and I would get positive 6, and that tells me that I'm going to use an x, again, because this is 1x squared, and this tells me I'll use the 6 right here. So to factor this x squared minus 8x plus 16, I'm going to do the same thing. I'm going to take the square root of my constant value here, which is 16. The square root of 16 is either positive or negative 4, but I could just take this negative 8 that I see here, divide that in half, and I get negative 4. Again, the leading coefficient is 1, so all I have to do is just say it's x minus 4 quantity squared. For this next one here, I would take the square root of 64, which is either plus or minus 8, or I could take this negative 16, divide it by 2, and I get negative 8. So I know it's going to be x minus 8 quantity squared. And then in our last example here, I could take the 25, take the square root of it, I get plus or minus 5, or I could take the 10, divide it by 2, and I would get positive 5. So I know that this is going to be x plus 5 quantity squared. Now, one thing I want you to notice is this 6 value right here came from dividing this 12 by 2. And when I get that value, if I were to square that value, I end up getting this 36 here. In this expression right here, if I take this value, this middle value here, and divide it by 2 and then square it, I end up getting negative 4, which is what we have here, and then I square it, and I get this 16, which is my constant value that we have here. The same thing is true in this expression. Taking this negative 16 and dividing that by 2, I end up getting negative 8, which is what we have here. But if I were to square that, I would end up getting a positive 64, which is this value here. And it works in this example because it works in any example as well. So I take this 10, divide that by 2, I end up getting 5, which is this number over here. But if I were to square that, I end up getting 25, which is my constant value here. Now, this only works because the leading coefficient in each one of these is a positive 1. And the reason why this works is because there are two ABs here. So when I divide the coefficient by, if I divide this 10 by 2, I get the 5 that I have right here. I get the B value that I have there. But that B is being squared when we multiply A plus B by itself. And that's how we get this B squared right here. So if we have a perfect square trinomial of the form x squared plus bx plus c, notice that this has a leading coefficient of 1. We can say that this b divided by 2, once I square that, will always equal the c value that we have here. So in this example, we're asked to rewrite the expression below with an equivalent expression that has a perfect square trinomial, and then we're going to factor that perfect square trinomial. So we're given x squared plus 6x plus 10. This is nice because my leading coefficient is 1. So all I have to do is take my b value, divide it by 2, and then square it. So my b value here is 6. So I'm going to take 6, divide it in half, and then I'm going to square it. So 6 divided by 2 is 3, and then when I square 3, I end up getting 9. So I will rewrite my expression, my x squared plus 6x, and then I'm going to leave a little bit of space, and then I'm going to write this plus 10 at the end here, because right now this is not a perfect square trinomial. I'm going to add this 9 here, but I'm not allowed to change my expression. So what I will do is if I add the 9, I'm going to subtract the 9 as well. And 9 minus 9 is 0. They cancel each other out. So I haven't changed my expression. I've just rewritten an equivalent expression that has a perfect square trinomial. So if you look here, this is a perfect square trinomial. So if I were to factor it, I could use x times x gives me this x squared, and then 3 times 3 gives me 9, and they're both going to be positive because my outer and my inner will give me the 6x that I am looking for here. This is where it's really important to know how to factor a perfect square trinomial, because you're not going to want to actually go through and factor it every single time. So I can recognize right away that it is x plus 3 quantity squared, and notice that the 3 is the value that we had here after we divided the b by 2. But we still have this minus 9 plus 10, so when I put together the negative 9 and the positive 10, I end up getting a positive 1. And this is my equivalent expression that has been factored. So I want to see, is my original expression exactly the same as my new expression? So if you notice in my top equation here on Desmos, it is the first expression as an equation of a quadratic, and if I turn it on, I can see this blue parabola that I have here. And then if you notice, my second expression that we have here is my second equation here with a y equals, and when I graph that out, it's my green parabola, and it ends up being exactly on top of my blue parabola because they are exactly the same. It means that they are the exact same expression. We haven't changed anything, we've just rewritten it with a perfect square. So in this next example, we're asked to rewrite the expression below with an equivalent expression that has a perfect square trinomial, and then we want to factor it. So we've got 3x squared minus 30x minus 14. Now in all the examples that we did at the beginning, the a values were all 1, but if you look here, our a value is 3. So the first thing I'm going to do is we need to make sure that our leading coefficient is going to be 1. So we'll factor this a value out of ax squared plus bx, but leave the c alone. So when we talk about a, b, and c, we're talking about standard form. We're talking about this ax squared, this bx, and this c. So that means that a is this 3 right here. Remember, we have to factor it out of ax squared plus bx, but we're going to leave the c alone. So I'm going to factor a 3 out. And when I do that, I have an x squared minus 10x left over. And I'm going to leave this minus 14 here at the end. By doing that, I now have a leading coefficient inside my bracket of 1, which makes things a lot easier when I'm trying to complete the square. Now we want to complete the square for our factored expression, or this x squared minus 10x. So I'm going to take my new b value, which is this negative 10 right here, divide it by 2, and then I'm going to square it. Well, negative 10 divided by 2 is negative 5. Don't drop your brackets because a negative number being squared needs brackets, so we know to do negative 5 times negative 5, which is positive 25. So I'm going to rewrite this expression up here as 3 multiplied by the quantity x squared minus 10x. And now I'm going to add this 25 to complete the square. This will become a perfect square trinomial. But if I add this 25, I have to subtract this 25. And then I can just copy down this minus 14. Now I want to keep my perfect square trinomial together, which means I want to get rid of this minus 25. However, this is technically 3 times 25, and this is 3 times negative 25. So if I'm going to take this negative 25 out of my bracket, then I have to distribute that 3 through. So now I will rewrite my expression as 3 multiplied by x squared minus 10x plus 25, which is my perfect square trinomial. Then I will distribute the 3 through to this negative 25, which is negative 75, and I will copy down this minus 14. Now all I have to do is factor and simplify. So I'll copy this 3 down, and this x squared minus 10x plus 25 can be factored as a perfect square. So I will get x minus 5 quantity squared. Again, check out the video on factoring perfect square trinomials if you need a refresher on this. And then I'm going to put this negative 75 and this negative 14 together, and I end up getting negative 89. So this is my equivalent expression to this 3x squared minus 30x minus 14 that we have up here. So again, I want to check to make sure that I did this correctly. So I'm going to graph out my first expression with y equals and as a parabola. So you can see in my first line here, I have y equals 3x squared minus 30x minus 14. I have my first expression. When I turn it on, I get this red parabola. Then if you look at my second expression that we have here, that's what I have written down as my equation with a y equals in my second line. And when I turn it on, my blue parabola is directly on top of my red parabola because they are the exact same quadratic equation, which means that this expression is equivalent to the original expression that's given to me. In our final example, we're asked again to rewrite the expression below with an equivalent expression that has a perfect square trinomial, and then we're going to factor. Again, our leading coefficient here is not 1, it is a negative 5, so I will factor out that negative 5 from my ax squared plus bx. And don't forget, we're just going to leave the c as is. So when I factor out the negative 5, this will say negative 5 multiplied by x squared, and then 100x divided by negative 5 is negative 20x. I'm going to leave a little bit of space, and then I'm going to copy down this minus 145. Now that my leading coefficient here is 1, I'm going to take my b value inside of my brackets, and I'm going to divide that by 2. So negative 20 divided by 2, and then I'm going to square it. So negative 20 divided by 2 is negative 10, and then when I square that, I end up getting 100. So this expression is now going to say negative 5 multiplied by x squared minus 20x, and then I will add in this 100, which has completed this square. So now I have a perfect square trinomial, but if I add 100, I need to subtract that 100, and then I'll copy down this minus 145. So I will keep this negative 5, and in my brackets, I only want my perfect square trinomial. So I need to get rid of this number in the brackets here, but because there's a negative 5 here, it's getting multiplied through to the 100, but that's okay because I'm keeping the 100 in my bracket. And it's also getting multiplied through to this negative 100. So negative 5 multiplied by negative 100 is positive 500. And then I will subtract 145. Well, again, this negative 5 just gets copied down. And then when I factor my perfect square trinomial here, I will get x minus 10 quantity squared. And when I put the 500 and the negative 145 together, I end up getting 355. So this is my final expression with a perfect square inside of it. You can also type both of these expressions into Desmos and graph them out and see if the parabolas will line up with each other, which they should, to show you that they are in fact equivalent expressions. So in summary, what you need to do is make sure to first factor out the leading coefficient from the ax squared plus bx to make the a value in your bracket equal to 1. Then when we complete the square, we divide the new b value by 2 and then we square it. This step completes the square. Then we add that value to the expression, but don't forget to subtract it to preserve the expression because we don't want to change the expression. Also, don't forget to distribute the leading coefficient that we factored out if necessary. So now you have a perfect square trinomial and you can factor it. All right, that's it for this video. If you have any questions, let me know in the comments below or at lulumath.com, where you can also find blank or completed notes for this video. If this was useful to you, please subscribe and share with others. Thank you, and we'll see you next time. Bye.